All right, so today we're going to talk about isosceles triangles. So the first thing we are going to do is just label what the sides of an isosceles triangle look like, and then the base and the base angles. So our sides are going to be AB and AC. Those are going to be our sides. And then the base then is going to be the bottom of the isosceles triangle, so that will be BC. And then our base angles then are going to be on the base, so that will be angle B and angle C. So with the isosceles triangle, we get some properties here. So we have a new theorem that is called the isosceles triangle theorem. So that says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if we have AC is congruent to BC, then we can say that angle A is congruent to angle B. So that is just saying if you have your sides congruent, so if your sides are congruent, then it's an isosceles triangle, and then your base angles are going to be congruent. Next, we're going to have the converse of the isosceles triangle theorem. So remember, converse, we just flip our hypothesis and conclusion. So that says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if we had angle A is congruent to angle B, then we can say the angles opposite, so AC would be congruent to BC. Our next theorem doesn't really have a name, so we just call it theorem 4 or 5. So this says that if a line bisects the vertex angle of an isosceles triangle, then the lines is also the perpendicular bisector of that. So if we have our sides congruent, so we have AC is congruent to BC, and then we also have that our angle ACD is congruent to angle BCD, then we can say that AD is congruent to BD, so that's what that means by bisecting, and then perpendicular, we can say that CD will be perpendicular to AB. So similar theorems with equilateral triangles. So if a triangle is equilateral, then the triangle is also equiangular. So if all of our sides are congruent, then that means that all of the angles will be congruent. And then the converse of that would be if the triangle is equiangular, then it is equilateral. So if all three angles are congruent, then we can say that all three sides are going to be congruent. I do want you to try to take a moment here to answer this question. So how many degrees are the angles in an equilateral triangle? So remember, a triangle has a sum of 180 degrees. So you can go ahead and pause the video and do that. So now we're going to look at some problems using these theorems. So we know right now, for number one, that since our sides are congruent, that means that x and y have to be congruent. So remember, I only have 180 degrees in a triangle, so I'm going to take 180 minus 50, and that's going to give me 130. And then, now that wouldn't make sense for both those angles to be 130, but I know they're congruent, so I can just divide that by 2. So I get 65 for x and for y. Now, the first thing I'm going to do over here is I'm going to, I know here that if I have my sides congruent and I have this bisected angle, that it's a perpendicular bisector. So that means that y is also going to equal 8 because those two segments have to be congruent. And then I have a triangle here. Well, I already have 90, so I'm just going to take 90 minus 58 to give me x, and that's going to equal 32 degrees for x. And then why don't you go ahead and try this last problem on your own, and I will check those with your notes when you're done.